Here we will be finding the derivative of the given function. So we'll start with the first one. It's fx equals arc square root of arc tangent x. So now we will be using the chain rule here, so which basically means we need to find the derivative of square root and then multiplied by the derivative of what is under square root there. So now let me show it to you here. It's f dash x equals square root is basically the exponent half, so we use the power rule there. So whatever is inside there, it will be having the exponent as negative half. So now this is arc tangent x multiplied by the derivative of arc tangent x, which is 1 over 1 plus x squared. It can be simplified further, like as we have negative exponent which can be moved to the bottom, and when the exponent is half, it can be written in terms of square root. So it goes on like 1 over half 1 plus it's simply arc tangent x multiplied by 1 over 1 plus x squared. So if you want to write the final answer, it will be just 1 on the top, and on the bottom it's 1 plus x squared, then radical arc tangent x, and that will be all for this one. Similarly, we will do the second one. So let's take the new page for that. So onto the second one. Here it's an application of second law of calculus, we call that. So where it goes like, we simply plug in the upper bound in place of t, and then multiply by the derivative of upper bound, minus just plug in the lower bound and multiply by the derivative of lower bound. As you can see here, the bonds are minus x and x squared, minus x and x squared. So it will be, so what we do here is f dash x equals plug in there the upper bound x to the third multiplied by its derivative. So simply I can write it in terms of derivative there. We can do the simplification part later, but just now set up in terms of the given rule. Similarly goes with the bottom here. There bottom, just replace whatever is given on the lower bound and then multiplied by the derivative of the lower bounds here. Okay, there it goes. Now we need to do the derivative parts. So it will be tangent x to the third multiplied by 3x squared minus tangent to the negative x multiplied by minus 1. So we can move those x squared things in front, then we write the tangent term, and there negative becomes positive, but tangent of negative x is negative tangent x, so which eventually becomes negative positive negative tangent x. and that will be the final answer for this one. Okay, similarly we will try the third one also. So it's x over ln x now. For this problem, what we do here is, as it is in terms of rational function, so we are going to use quotient rule. The quotient rule goes on like, if the derivative is of function top and bottom, so you can simply write it as f dash, which is the derivative of top, multiplied by the bottom function as it is, then again the top function as it is, multiplied by the derivative of the bottom, and then the bottom squared. So this is how it goes here. So we apply this rule here. Let's see how does that looks. So f dash x equals derivative of x, which will be simply x dash, just write it as x dash. In the next step we can write its derivative, so multiplied by ln x minus x as it is, multiplied by the derivative of ln x over bottom squared, so which is simply ln x, so ln x will be get squared there. So now we can simply plug in there 1 time ln x minus x times 1 over x, so ln x is squared. Now it ln x minus 1 over, so we just write it as simplified form, and that's all.